w. So a plus b whole square is a square plus 2ab plus b square. A minus b whole square means a square minus 2ab plus b square. So these are one.
You said a square minus b square.
And these two are important always. Anyways, sorry. So a square minus b square is the third one, which is important. A square minus b square means a something square minus something square, perfect squares. This is equal to addition into subtraction. A plus b into a minus b. How do you write this?
X plus 6 minus 6.
So the product of addition and subtraction. So yeah, what happened?
I wrote it really bad.
Okay, so what if you write, let's say x minus 36?
That's just x minus 36.
6.
Unless you have it root x.
Okay.
Plus 6. Root x minus 6.
Okay. Yep. Yeah, so let's say 9 by 4 minus x squared. How do you factorize this?
That's 3 over 2 minus x. Over 2.
That's it. Okay. So this is about these products which are important to remember. See, when I say a square minus b square is a minus b into a plus b, it goes without saying that a plus b into a minus b, the answer is
a square minus b
a
square.
square minus b square. So going from here to here, here to here, the flexibility is important. So this concept, this formula which we are going to use in rationalizing the surds.
Okay.
So basic rationalizing I think you know already. So multiplying the number by itself, multiplying the denominator by itself. So if the question was something like this, let's say root 6, what you can do is either option A is multiply by itself. This is brute force method. Option 2 is identifying that root 3 by root 6 can be simplified. This will be root 3 upon, this is root 3 into root 2. So root 3 eliminated. So 5 by root 2. 5 by root 2 means like this, okay?
Yeah.
So same thing. So this is the brute force method when the denominator consists of only one term. Obviously, let's talk about different cases. Let's say 1 upon root 3 plus root 2. In this case, denominator has how many terms? 2. The brute force method does not work, like multiplying the denominator by itself. Can you guess why?
Because it would just be root 3 plus root 2 over 3 over 2 plus 2.
So if you multiply the denominator by itself, let's say like this.
Oh wait, no, then you have to do like brackets stuff.
What happened?
You have to do like root 3.
So when you multiply this product, you get root 3 plus root 2 whole square, which is 5 plus 2 root 6. So root 3 square plus 2 into root 3 into root 2, 2ab plus b square. So 3 plus 2 is 5. and then 2 root 6. So in the denominator, we still see that there is still a irrational term. So technically, this method, this brute force method, did not work because we are not so successful in rationalizing the denominator. Rationalizing the denominator means what? Whatever the term which is down, this has to be
not have a surd.
Yeah. So that is when we can say that uh, denominator is rationalized. So basically, obviously, so the brute force method does not work. How do we solve this question is, we use the number 3. You remember the number 3 formula?
Okay, a squared minus b squared. Yeah.
Or a plus b into a minus b is?
Yeah.
That, right? So there is a plus b here in this question, correct?
Okay.
So you have to multiply with what?
A minus b.
A minus b. That gives the answer a square minus b square. So what is a minus b here?
Root 3 minus root 2.
Root 3 minus root 2. So you multiply by that. So what is the denominator value? How much?
3 minus 2.
And then the numerator, what is left? What is the answer in the numerator?
Root 3 plus root 2.
Root 3 minus root 2, okay?
Oh yeah.
So root 3 minus root 2 upon a square minus b square. A square minus b square. So root 3 minus root 2 in the numerator. The denominator is just 1. 3 minus 2, which is 1. So the denominator has been rationalized. Do you get it? So the number 3 formula is going to be useful when we are talking about the topic rationalizing the denominator.
Yes.
Okay. And then see in the very first case we had one term in the denominator.
Okay.
In this case we had two terms in the denominator.
Okay.
Let's say, this is a bit advanced. Let's say if there are 3 terms in the denominator. Okay.
Okay.
How do we rationalize this? The method is, not bad, but it's the same method as we followed earlier. It's just that you have to consider these two as single quantity, or any two things as simple quantity. So this becomes A, this becomes B. So A plus B is in the A plus B is in the denominator. So you have to multiply by what?
Okay.
A
minus.
Okay. So what is A here?
A is 2 root 2 plus root 3.
So root 2 plus root 3 minus B means minus root 5 upon like this. I have to multiply divide that. How do you solve this product? Can you tell me? Any guess?
Can I just write as a table?
See, what did I teach you just now? How to solve these types of questions?
Okay, a squared minus b squared.
A square minus b square. What is A here?
Root 2 plus root 3.
So root 2 plus root 3, this entire thing has been squared. Okay? Read out.
It's 5.
Minus root 5 square, which is 5. Okay?
Okay. Is this not also 5?
Yeah, root 5 square is 5. That's what I'm saying.
No, I mean this one is 5.
Well, here it's a bit tricky. This corresponds to what format? 1, 2 or 3? Which format?
1.
1. So you have to apply that formula. What is the formula? A plus b whole square?
A squared, which is 2. Plus 2ab, which is 2 root 6. Plus b squared, which is 3.
Can you simplify this? So did you notice something? The denominator has been reduced to how many terms?
1.
And what was in the numerator? Fill this also. So this is in the numerator. So in the denominator it is 2 root 6. So to rationalize it further, I think you know how to do.
You multiply by root 6.
So this is the way when there are 3 terms. This 3 terms is a bit advanced. Maybe in the syllabus, may not be in the syllabus. Just to make sure to understand the concept, I'm taught you this. Okay. So these 3 formulas, number 1, number 2, number 3. Like let's be also b whole square, a square minus b square, are important.
Yeah.
So this is the question. 1 over 1 plus root 2 root plus 1 over root 2 plus root 3. Again, root 3, root 4, 3, 4, 4, 5. 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. Like that, so on up to 99, 100.
Would it be 1?
Okay, how?
1 over root 100.
These are all fractions, you know, right?
Yeah, so if you have to multiply all the denominators, you make these cancel out.
Multiply?
Yeah, to get the same denominator.
See, in each of these terms, this, this,
yes,
the denominators, if you notice carefully, they all differ by 1, 1.
Yeah.
So even if you write this 1, this is nothing but root 1.
Yeah.
So there is a pattern. See, if you look at individual terms first, let's consider the first one. Did we do these types of questions before?
Yeah.
What is the topic name?
Rationalizing.
What happens if you rationalize this?
It turns into root 1 plus root 2.
It turns into?
No, it doesn't. It turns into root 1 minus 3.
How it is 3?
Oh, 1 minus 2, which is minus 1.
Minus 1, right?
But you can't have minus on fraction.
Minus 1 is in the denominator, right?
Yeah.
So you have said like this, right?
Yeah.
So this will be minus 1. The numerator it is root 1 minus root 2. This is still rationalized because there is no root here. The thing is, if you want convenient, if you want to write simply this minus, because of this minus, the answer becomes like this: root 2 minus 1. Positive root 2 minus 1. Minus 1.
Oh.
Okay. So basically, this becomes root 2 minus 1.
Okay.
So similarly, next one is root 2 plus root 3.
Okay.
This becomes
root 2 minus root 3.
Root 2 minus root 3 upon
root 2 minus root 3.
2 minus 1. 2 minus 3 is 1.
Yeah, which is 3 minus root 2.
Root 3 minus root 2. So similarly, 3 and 4. See, instead of writing 3 and 4, how about we write 4 and 3 like this?
Okay.
So it becomes root 4 minus root 3 upon
minus 1. 1.
1. So basically, large number minus smaller number, correct?
Yeah.
Large number minus smaller number. So that is what it is happening. So the scroll down. So the question actually becomes, the first term is large minus small, root 2 minus 1 plus 3 minus 2, 4 minus 3, correct? So on, at the end, what happens for the last one?
Root 100 minus root 99.
Good. Okay. Did you notice something? Well, this addition, this simplification.
No.
Wow, seriously? Hmm.
Everything cancels out.
So we have to be a bit careful because what exactly cancels out, right?
1 does not cancel out and 100 does not cancel
100 does not? Yes.
cancel out.
Okay.
Plus this equal to 9.
What about root 99? Will this survive?
Because in the one before will be root 99 minus root 98.
That is positive root 99, which will be eliminated by this. This.
Yeah.
So that is the answer, okay? So there is a series. So the first of the first term, okay? So the first term in the bracket is eliminated by next one in the second one.
Yes.
So first one in the bracket has been eliminated by next one in the next term, like this.
Yes.
So this term might have been eliminated. This root 99 term. So root 99 term might have been eliminated here. But to cancel this, we'll be obtaining somewhere after this.
Yeah.
So there is no sequence after this term. So root 99 is the survivor. And root 100 is the survivor. So like that. So root 100 is left, and similarly root and negative 1 is left. So 9 is the answer. So this is the way.
Parallel lines never meet.
So geometry.
Perpendicular lines meet once at a 90-degree angle.
So when we are talking about linear systems, in terms of slopes, what can you comment on parallel lines and perpendicular lines?
Parallel lines will never meet. Perpendicular lines meet once at a 90-degree angle.
Okay, my question was, what can you comment on the slopes? Let's say this is line 1 and line 2. What can you say about slopes of parallel lines?
The same.
So parallel lines means same slopes.
Yeah.
What about perpendicular lines?
Negative reciprocal.
Negative reciprocals of each other. Okay.
Yeah.
So negative and reciprocal means flip the fraction. So let's say this is line 1 and let's say this is line 2. Okay.
Okay.
So slope of line 1 is, let's say, minus 2 by 3. What will be the slope of line 2 in this perpendicular lines?
3 over 2.
Positive 3 over 2. That's it.
Yeah.
Let's say slope of first line in this left case is 0.0001. What will be the slope of line 2?
Wait, what? The same.
0.0001. Okay.
Yeah.
Same. So for parallel lines, same slope. Next is equations of lines. You know how to represent line equations?
Y equals mx plus c.
Is that all?
Yeah.
Basically, like that, there are 3 forms. Okay, 3 forms. What you said is called slope intercept form.
Okay.
There are 3 forms. First one is general form, general or standard form, which we write like this: ax plus by plus c is equal to 0.
Okay.
And when we are solving elimination and substitution method, you might have come across these types.
Yeah.
So general form is when all of the terms are on one side or the constant is on the other side, like this. So this is called general form or standard form, the first one. Second way of representing is the one which you know already, I think. Slope intercept. So
Yeah.
there is a slope. Yes. So there is a slope in the formula, there is also an intercept in the formula. So slope m, let's say b. C or b, what do you use?
For what? B is.
You use b or you use alphabet C or C intercept?
Intercept is C.
Okay. Yeah, USA they use b, but anyways. So y is equal to mx plus c.
Yes.
Okay, let's say the line is something like this. This coordinate is 0, minus 2. This coordinate is 2, 0.
Okay.
Slope is given as, let's say, 1. Write the line equation for this line. That's it. So x minus 2. So slope is, when y-intercept is this point. So where the line is touching the y-axis is called y-intercept. What are the coordinates of x-intercept?
X-intercept y0.
Coordinates are, looking at this graph, coordinates of x-intercept.
2, 0.
Okay, so that is the thing. So x is equal to 0 for y-intercept, y equal to 0 for finding the x-intercept. Okay.
Yeah.
So this is about slope intercept. So number 3 is point slope. Okay, point and slope. So as the name suggests, there is a point through which the line is passing and slope of line.
Okay.
So let's say if there is a line, it is said that, okay, let's say there is a line like this. It is given that it is passing through one specific point, any specific point which is highlighted, x1, y1. It has a slope of m slope. So the line equation formula is, listen carefully, y minus y1 equal to m x minus x1. Okay.
Okay then.
It's a bit similar to change in y upon change in x is equal to m. So that is the thing. It's just that there is a variable y, variable x.
Okay.
So it is given that, let's say, a line is passing through a point 1, 0, and it is also passing through a point 3, 2. Find the line equation. Try this question.
The line equation, that's the first one, right?
See, whatever we discussed, the three forms, they're all forms of line equations.
Okay.
General form of line equation, slope intercept form of line equation, point slope form of line equation. These are the formulas which I have highlighted and which I have written earlier. This, and this.
How is this 3, 2, and 1, 0?
It is given that it is passing through 2 points. See, coordinates.
Why is 3, 2 near the bottom?
See, it doesn't matter, okay? I mean, it's just a rough diagram. Objects not drawn through scale. Fine. Okay. That's okay, yeah. That's one way to do it. The method is called slope intercept method, right?
Okay.
Okay, if the question is find line equation using point slope form, right?
Okay. Minus 1. Oh, m is 1.
X minus m, that is. So m is 1. Okay.
Okay.
Okay, so basically, see in y minus y naught, okay?
Okay.
Why did you adjust that? What happened?
Oops. Okay.
See in y minus y1, what do we need to choose y1, x1 as?
I did it this one.
Okay, in y minus y1, what did we choose x1, y1 as?
Y1 is 0 and x1 is 1.
So basically, can we also choose 3, 2 instead of 1, 0?
Yeah.
That is the point. So even if you do like y minus y1 is 2, right?
Okay.
That is equal to slope, which you have found this slope into x minus 3. Can you simplify this? Check if the answers this one
Yeah.
and this one are the same.
Y minus 2 equals x minus 3 equals x.
So same thing, right?
Yeah.
What about this answer?
Yeah.
This. That is also
Yes.
x minus 1, right? So the answer is same. The methods convey the same thing. So this is how we use different forms of line equations and the formulas, respective formulas.
Okay.
So if I say, if this is the line equation, convert this into general form. How do you write that?
That's the ax x minus y minus 1 equals 0.
That's it. So general form means bringing these terms together. That's it. Or
Slope. Okay. Point.
slope intercept.
Slope intersect. So this y equals 2x minus 3.
That's it. What is the slope? How much is the slope?
2.
Oh, okay. Okay, if a general form of line equation is given, let's say come to the next page.
Okay.
Let's say if general form is given, let's say 2x plus 3y minus 5 is equal to 0.
Okay.
Slope is how much?
Slope is 3 over 2.
3 over 2?
2.
Hmm?
Because if you put it into, it would be 3y equals minus 2x plus 5.
You're writing something? Okay.
Yeah. Oh, my bad. Minus 2/3 x plus 5 over 3.
So what is the y-intercept?
Minus 2/3.
Y-intercept.
Yeah. Oh, plus 5 over 3.
So this is the slope. That is the y-intercept. Okay. So basically we have a formula. If general form is given, to save time, we use minus a by b. Okay. We write something like ax plus by plus c is equal to 0, right?
Okay.
So by looking at this alone directly, instead of converting this into like this and finding the answer at the end, instant answer is minus a by b. A means coefficient of x, b means coefficient of y. You know coefficients, right?
Yeah.
Numbers which are multiplied to the variable are called coefficients. Numerical values. So basically minus a by b. Simple, right? So minus 2 by 3. Directly that can give the answer. So this is important to remember. These are applications. So that's about different types of lines. So let us understand that. Let's say there is a line. Okay. There is a line.
There's a line.
Which passes through.
Passing.
Let's say coordinate minus 5 by 9 comma 1 by 3. passing through a coordinate minus 5 by 9 comma 1 by 3.
Okay.
And it is parallel to y is equal to 5x plus some b line. What is the equation of line? This line.
So it has to have C parallel. So we should have this. Y equals 5x. So y is 1/3. And then 5x is minus 25 over 9. Plus c. And then we go to the side. 1/3 plus 25 over 9. Which is 3. Which is equal to c. C is equal to 9. Or
Okay. Yeah, 3 1 by 9. Okay. Fraction plus. That's it. Let's say same question. Part B of the question is. So let's say this is part A of the question is parallel. Part B of the question is perpendicular. Same question, same numbers. Just that instead of parallel there is perpendicular condition.
So this is this. So a line perpendicular to this would be y equals 5x plus c. Yeah? These coordinates. Okay. So we have 1/3 plus x. No, which is x. Plus c. So this is 1/7. So 1/3 minus 1/7.
1?
And this, oh, 1/9. So equals 2 over 9 equals c.
Okay. So you can erase this C and directly paste 2 by 9.
Equals
Plus or minus?
plus.
Plus, right?
Yeah.
So that is it. One alternative way is we can use the point slope form. Point slope is what? See, we have the slope for first condition is 5, right?
Okay.
So y minus y1 is mx minus x1. Like this.
Okay.
x1 y1 is given in this case. So y minus 1/3 m is 5 into x minus like this.
Okay.
So same thing, same result, method is different. And then when it was minus 1 by 9, when it is perpendicular, case B, I have to just use write as it is, but slope is minus 1 by 5, right?
Minus 1 by 5.
So minus 1 by 5 into x minus 5. So same thing, we'll get the same answer like this. Okay.
Can I get water?
So let's say there is a circle, okay?
Okay.
Center is given. Let's say
This is a tangent. It's supposed to touch the circle.
do you know equation of circles?
It's like x squared plus y squared equals r squared.
What is the center of this circle?
I don't know. 0.
Origin. 0, 0. So basically,
we only get questions with 0 is the origin.
Well, that might be during the year 9, maybe.
No, for like
Really?
our teacher told us.
In entire GCSE, is not like that.
It is like that.
So then let's say the center is at the origin like this.
That is totally the center.
So let's say there's a point here. Let's say 1 comma root 3. Okay. Draw the tangent line at point P 1 comma root 3. Okay, let's say point A is 1 comma root 3. Tangent line equation. Line, right? Line equation. What is the tangent line equation at A? Point A. How do we do that?
This is 0, 0. So that's to get from this is 1 and this is root 3. This is root 3.
So perpendicular to this line, I see. Tangent will be something like this.
Y equals root 3x. Okay.
So y equal to root 3x.
Y
will be
equals 1 over root 3 x. So I should go like this.
Look again, should it be 1 over root 3 or something else?
Wait, wait, wait!
Hmm.
Yeah, this is this.
See, for all questions, it seems like you are following slope-intercept formula, right?
Okay.
See, there is another method which is called point slope method. Okay, that is more reliable than you might be thinking. So point slope.
So y minus root 3 equals minus 1 over root 3 x minus 1.
See, one step answer. So like this, you can obtain the answer. So this is the answer. And if you want to simplify, you can open this brackets. Okay, why is this plus 1?
Because 1 over root 3 plus. Oh, no, it's not going to be root 3. Over 2 root 3.
See, 4 over the common denominator. Root 3, that is.
Oh, yeah.
Yeah, 4 over root 3. Any doubt? Root 3 only, not 2 root 3. Any doubt?
No.
Okay. So that is the answer. So minus 1 by root 3 into x plus 4 by 3. Okay. 4 by root 3. How much is the y-intercept?
4 over root 3.